Alright, so this is the video which uses the cross product for a simple problem involving magnetism. And here we have another property that I forgot to mention, is that the resultant vector from a previous video is perpendicular to the vectors that are crossed to bring this vector into existence. So C is perpendicular to A, C is perpendicular to A, and C is also perpendicular to B. But that should be obvious based on the positions of the hands, because every vector is perpendicular to the other in 3 dimensions. So let's assume a long conductor here, and here you have a very small section of the length of the conductor, which we will assign a value of ds, and we have the current flowing in from here, and we have magnetic fields that go this direction. So we have a bunch of magnetic fields that go this direction, and we give them the value B. So what we want to find is the force that that is exerted in this small section, this ds, by the magnetic field. So we have the formula that you've probably studied, is the force is equal to the current times the length vector crossed with the magnetic field vector. So what we have here is a classic equation that is comparable to this, what we had here. So the current is obviously a scalar thing that we don't have to take into account. It just comes in after we calculate this part. So what we have here is F is our C, and L is our A, and B, of course, is our B in the equation C equals to A cross B. So if we draw the axis here and say that this is towards the y-axis, and the magnetic field lines are going opposite the positive z-axis, and here's our x-axis, then we will have, basically we will have, what do you call it, A cross B, which, so C equals to A cross B, and A is our length vector, and B is our magnetic field vector. And the length vector is always in the direction of the current. So that's a basic property. So what we have here is that the length vector is in the direction of the positive y-axis, and the magnetic field vector is in the direction of the negative z-axis. And we have to basically find which direction the force is in. So what we do here is that we take our right hand, and we take our first element in the cross product, which is the length vector, and we point towards the y-axis. This is our index finger. And we take the second element, our B, our magnetic field, which is pointing in the negative z-axis, which we take to be downwards. So we have this, which my index finger, which is the length vector, and my middle finger, which is the magnetic field vector. And what we have here is that if we point this towards the y-axis, then we will find that the force is acting in the negative x direction, because then you have the middle finger that goes opposite the z-axis, and we have the index finger, which goes in the positive y-axis, so our force goes to the left, which is the negative x direction.